George Flick. George started the CFAS program, started the Sea Grant program in 1969, and he and Lori got a special interest to make sure this model is developed. I've had the privilege to be in Dr. Zobel's class this fall, and had the privilege to work with 3 outstanding young men. Thank you for getting that on tape. What they're going to do this morning is go through their model, and as each one of you begin your presentation, then it is mirrored after the one they gave in class, only extended a little bit. We would ask you to just talk a little bit about yourselves. My concentration was the model, and I didn't get into your backgrounds that much. So, Sam, are you going to begin? Okay, he's going to begin, and then Tarun, and then Chandan will demonstrate the model.
Okay, this is Hussam Almulhim. Graduated from KFUPM, King Fahd University of Petroleum and Minerals from Bahrain, Saudi Arabia, from the Department of Finance. And I got my, I worked as a graduate assistant there for 2 years, and I got my scholarship to continue my studies for an opportunity to get back to be a faculty member. I had now the privilege to get my master's from Virginia Tech, from the Masters of Information Systems, where I feel this is my specialty area. I happen to have a good real background in programming, class designing, much more in that direction, really. That's where I see myself. Although I'm not sure if this explains much about me, but at least I just want to. The aquaculture economic cost model. Now, I'm not sure if you had any experience with the older versions of the model. Did you? No? Okay, good. So the purpose of it, you probably know about it, it's just to support decision makers who are in the industry to make the right decisions regarding investing in the agricultural business. Now, we're going to go through these entry component introduction. We're going to be discussing about the project progress, and Tarun will go next to speak about the major problems we faced, and then about the upgrades we've done in the system. The model demo will then be run by my friend Chandan, and then we'll just give you our expected and future output of the system and what can be done. The research-related agricultural system is a system that would give the yours, even though you know it, but for me as not a specialist, I would like to always reference this from the definition. Aquaculture is the cultivation of aquatic creatures. It's like fishing, but you fish in a controlled setting where you have different tanks producing different kinds of fish, where the aquacultural personnel would be really much involved in feeding the fish and taking control, whether it's fish, shrimp, or even pearls. The ACM, as I described, the goal is to support the decision makers, to give them the right information, at least to guide them to the right decision at the end. Now, part of the just information to make this as important as it seems is 31% of the total production of aquatic creatures are from these systems. So that is why this industry seems really important to invest in. And they're expecting a 10% yearly growth rate, which is really a lot. The old version of the model, as you probably remember, focused on the strategic support to decision makers, regarding the operational decisions. Version 2.23 included loan decision support and input scheduling support. Our upgrade mainly is composed of a simulation component added to the system. As you know, the system should only be used by two working people together, a financial analyst and aquatic analyst. Maybe you can move next to discuss probably the goals. Now, in our project progress, we have one, in this probably semi-project-oriented project cycle way. We did our analysis. It took us a while. The model was like really big, and these really required a lot of time just for us to understand and know what is the purpose of it. We spent a lot of time trying to derive what is the real goal of the system, reading much documents, and what confused us is that the previous team has included some components that made us really not really sure of the purpose and the goal of the system. And that's why we had an opportunity also to meet the people, the first team who produced version 1. And I see it as the most really valuable thing that ever happened to us, because we really at least met some people who knew what was the purpose of making this system. I really would like to thank Travis and Jennifer. They were there when they really at least gave us a hint of what is the purpose of it. And it's a DSS oriented. Special components were in the version 2.23 that made it not really a decision support system. That really confused us. Ideas have been roaming starting the semester, dealing with adding a database component, and is it feasible, because we have tank sheets, we have sheets that really was not really decision support oriented. They're just sheets that facilitate inputs, daily inputs from analytics that doesn't really support the real essence of the system. With shifting plans, meaning that we just focused, we know now what are we targeting after we realized. We organized, we implemented, and we successfully at least documented and have a deliverable component at least. I would like to hand it now to Tarun, where he can discuss some of the problems that he faced.
All right. My name is Tarun Chaudhary, and I'm an MBA student. I'll not go into much details of introduction because I don't want to break the flow here. So let's just take a look at why we are here and why did we work on this and what all did we work on this. So problems with the older model, the version 2.23 as we took off. So when we saw that particular model, when Charlie introduced that model to us, he did give us a lot of things that he had in mind, that there are certain things that are not working. So these are the certain problems that we charted. So the first one was it was a very bulkier or a varied system. It has got 7 different workbooks, and all of them were interacting with each other, and when you are working on one particular workbook, you have to have the other workbooks open and all those things. So there were a lot of problems, and it did affect the performance of the system as well. When you click on one particular button, it might go to some other workbook, and it would take some time depending on the processor speed. So that was one of the challenges that we had to face. And the second one was poor documentation. As Hussam said, that initially it took us a lot of time to get to what exactly the purpose of the model is. But that was mainly because we didn't have a proper documentation there. So we didn't have all those things about the model. We had the documentation for the aquaculture, we know what the model is doing, but how it has been designed, what different sheets are doing, what different buttons are doing. So that all we need to go and browse through them so that we can get to know what exactly is that. So that was one of the major problems there. There were some links that were not working, and if I click a button, it doesn't go to what it should do. Some of the cell references were wrong, so all those different kind of problems were there. Then shifting the focus, like if I click on a button and if it is taking me to a different workbook, it might not take me to the exact location where it needs to go. So it takes me to some different cells or some different, some different ranges, right? So that was another problem. Then there were certain unwanted elements there, like the tank sheets. I mean, those are not unwanted, but definitely as a part of decision support system, because the tank sheets were being used as a regular day-to-day work. So that was not a part of your DSS. So we separated that out from this particular system. Then finally, the system is pretty static. Like there are certain constants which have been hard coded into the cells, and if I want to change those constants, I need to go to each and every cell and make those changes. Plus, if I just provide certain input values, those input values are always constant, and they give me a particular result. So if I want to change or see some randomness, if some factors change or something like that, that was not there at all. So it was completely static with no randomness in it. Okay, so after seeing all those problems, what different things we did, so to improve this particular model, which in a while we're going to explain to you. Okay, so these are the three different perspectives that we looked at the model from. The first one was the system improvements. So that was from the developer's perspective, like whatsoever problems we saw in terms of links, in terms of performance, all those things. Those were there as a developer's perspective, and he was the one who has to work on removing all those problems. Second was the simulation model, which was from the user's perspective. If I want to see that if my variables change, how my results are going to differ. So all that kind of simulation part has been included into this, which is one of the major enhancements in this model. We have included an entire new simulation model for this particular into this, so that when you want to see the changes as the variables change, so that now system can handle it automatically, and you don't need to go and change the values each and every time manually. Then finally, the documentation part that I talked about, that was not very comprehensive earlier. So we worked on that as well and prepared the documentation for the users as well as for the developers, so that in case some developers want to take it up further, so they can read through the documentation and know what exactly is there in the model, and they can take it up from there. Alright, let's just take a look at them one by one now. Systems improvements. Okay. So as I talked about these problems earlier, so these are the major ones that we saw, and we worked on them to resolve these particular things, like the links that were not working, they were corrected. So I hope that now there is no particular button when you click on it and you find a debug error or something like that. Second was the dirty code that was there. I mean, the code that was written earlier, although it was working, and there were certain problems with it, but it was not structured in a very good way. I mean, there was code written here and there, and it was all haphazardly written. So we just structured that and created, cleaned whatsoever was not working, and included whatsoever we wanted to. The file size, earlier as I said that there were different workbooks. Now what we did was during the stages, we earlier worked with different workbooks, removed the tank sheets, then we had 5 workbooks or so with us, and then we worked on those, and finally we merged all of them together to one workbook, so that we have a single file that can work for us. So it will give us the same functionalities plus some enhanced features that we have included. Then there are certain, we have developers worksheet, which contains certain values of constants that have been picked up from there into different worksheets. So that's a completely developer worksheet, is a separate area for the developer only. So users are not, users don't have to be bothered to go to that particular area and work on that. So if required, that system can be logged for the users as well, or can be password protected as well. Okay. The next one is your named ranges. Like earlier when we talked about the formulas, it says A1 plus something something something. So that A1 might change as we include some other cells. It's not a problem if we are working in a single workbook, but if we are working in multiple workbooks, if a second workbook is not open, and if you change the references in the first workbook, it is not going to change the formulas in the second one, right? So that was one of the problems. So we changed those references, those absolute self references to relative self references, or we named those ranges. And when we named those ranges, it became easier for us to use them in the code as well as in the other workbooks or formulas. Although we would merge the workbooks later on, but earlier when we were working on this, so it helped us a lot. Then what the value we added was it became easy for future upgrades because of the documentation that we did, and whatsoever things have been included there, whatsoever code is there has been properly commented, and all those things are there so that it becomes easier for the future developers to develop this. And the worksheets are pretty flexible now because all of them have been merged into one workbook, so you can play around with the worksheets whatsoever you want to do, and you don't need to worry about if you want to change something in one worksheet, so it would not change in the other because it's in the same workbook, so it would not create a problem for you now. Okay, system improvements, we continue with them, is remodeling VBA. That was one of the major things that we did. As I said earlier that we changed the structure of the VBA code that was there. Earlier there was just few lines of code. I mean, there was not much of the code earlier. So there were just few codes in some of the sheets. So what we did was we created certain sheets in one workbook, and then we had those modules. So we have removed the entire code from the sheets and kept them in the modules so that it is accessible from the sheets or from workbooks from anywhere. So when we define the codes in the modules, all the variables can be used by different sheets and different the main workbook. So it becomes easier for the developer to work with those variables and use them anywhere he wants. So that was one of the major change that we structured the VBA code into modules, and it became easier for us as well as it will be easier for the future developers. As I said earlier, we eliminated the hard-coded references like A1, A2, A3, all those things were there. So we tried to remove as much as we could, and all those things that were being used in the calculations and all those things, we tried to remove that. Okay, then we had, because of this, we had easy upgradable systems and documentation that whatsoever we have prepared. So based on the new model, we prepared all that documentation that becomes easier for the users to work with the model. Okay, let's just take a look at the revised model now. This is the different part of the information that we have in the that particular model. Like the main sheet, the AECM version 3.0, which is the only workbook with us now. But earlier these were different workbooks. The AECM version 3.0 or 2.23 was the earlier version. So this was there earlier where all the user inputs were being fed into this particular sheet, right? He used to put in all the cost of production, all the loan information, electric equipment cost, and all those different things. He has to put into this particular workbook, so that all this information is taken up by these different worksheets, the loan information, the cost of production, and the financial statements. So it is picked up by all these worksheets and then being worked upon on various formulas to generate different values, right? This financial statements and the cost of production, these particular three sheets, they also interact with each other as well. Like if I put in certain input values here, it is being used by these things, but the values which are coming out to be in these three sheets are being used by each other as well. Right, so it was, without the documentation, it became very difficult for us to figure out all those things, that what different relations are there between these sheets, what sheets are interacting with each other. That was not at all there earlier. So we tried to put this model in place so that when a developer looks at it, he has a basic idea that what sheet is interacting with what. So the information flow is some kind, it's kind of clear to him. What we did was all these different sheets were there, all these workbooks were there. What we finally did was we merged all of them together and we made them as one workbook into the AECM. All of them were together in a single workbook, so they're interacting with each other, and it has improved the performance a lot as well. Plus the size is also reduced from about 6 MB to 2.2 or something like that. So, alright, the simulation part. That is the next level of enhancement that we've done here. What we did was, there was a certain amount of variables which are there. Like when I put in my variable costs, so there are different costs there, cost of fish, cost of fingerlings, and all those different variables are there. Now I put in all those values and I calculate my incomes for the next year, I forecast my income for the next 3 years, generate my financial statements. Now what we did here was we introduced certain randomness in those variables. Instead of providing a single value, we just provide an upper limit or lower limit, or we provide, or if we want, we can change that to mean or mean. We can provide the mean value and the deviation from the mean and all those things. If we want to use the normal distribution and all those, so we can use that. What we have done is we have provided an upper limit and lower limit columns instead of one single value. So you can provide all those upper limits and lower limits for all those variables, and when you try to generate the simulation, every time it generates a random value between those limits, and based on that it calculates all the different worksheets, information what is there, and finally forecast the information for you. And then you can generate those informations for the income for the next 3 years. You can generate as many simulations as you want there. So how it is being done, it would be demonstrated to you by Chandan in detail, and I'm just giving you a brief idea about that. Now the world is all after pictures, I can give you a huge table of data with incomes of 3 different years. This is the first year income, this is the second year income, this is the third year income. But you have to go through each one of them to see, okay, this is more than this is less than this. So if I give you some kind of a graphical representation of all that, it would be much easier for you to comprehend what exactly the information is saying, right? So that graphical interface is also included here, where it gives you a chart of your simulations of incomes of the next 3 years. So it gives you all the graphs. Your income for the next year would be what, and your income for the next 2 or 3 years would be what, based on the number of simulations you've done. And then we have eliminated some components like the tank sheets, as I earlier said. So that was one of the major things that we did. Finally, we enhance the user's perspective through the some kind of documentation things. Easy deployment means that now that you have one single file, it becomes easier for you to put that into any place in the hard drive. Earlier it was a necessity for you to put that in a particular directory as C:/business analysis. You have to create that folder and put all the files in there, otherwise the model would not work. Right now, what you can do is it's just a single file, so you can put that file into anywhere in your system and start working on it. It becomes easier for you. Then your user manual has been created, so it becomes easier for the users to comprehend with the information which is there in the model and work on the model. Developer's guide has been created, which contains that particular workflow that I just showed to you in the previous slide, and it becomes easier for the developers to pick up quickly that what information is flowing from where, and then he can go to those particular sheets or modules in the VBA code to see what is happening. The last thing is your injected AECM papers, like those information are about all those AECM things, which was not included in the model earlier, so we just included that as well. So I would not say that it's just one single file of Excel, so it has certain papers like a PDF AECM file as well as the developer help as well, right? Okay, so that was all about what we did and what were the problems that we faced. So I'll now hand it over to Chandan, because he's the one who's going to explain you the entire model now.
Hello everybody, I'm an MBA student here, and I had a background in computer science engineering and IT consulting. So when Dr. Charlie came up with this live project, I was the first person to jump on it. Okay, so let's start the model demonstration. So here's the aquaculture cost economic model, and version 3 we named it because we have gone through a very large overhauling of the system that was there earlier, so we named it version 3. And earlier we had only one user interface which has all the different, you can see there are 9 different user inputs for various variables. but now we have integrated another component into this, that is the budget estimates. And we have three options here, that is for employment, feeds and feeding, and system. So let's say we go to employment, we get this user interface where now, for example, hours of work. Now this cannot be something which is fixed. So the user has the flexibility of entering the upper limit and lower limit. So I entered here something like 1,000 hours. So it randomly generates value here. Now the purpose of generating a random value is that it helps to better capture the probability of value occurring, because we don't know for sure if the upper limit would be there or the lower limit would be there. It can be anything between that. That's why we introduce this randomness into the variable fields. So once we have this random variables here, these go back to the user interface and fill in the variable fields here. Now some of them are constant values, some of them are variables. So the variable values are picked up from the budget estimate sheet. We are working on integrating the budget estimate into the user interface and eliminating some of the user interface. But as of now, it's as a separate component. So there might be a bit of duplication, but we'll get that fixed up. So once the user data is there, the free statements, if you remember the model somewhat, it had a loan information sheet, it had a financial statement sheet, and it had a cost of production sheet. And just as Tarun said that they interact amongst each other, the loan information sheet is actually the one which takes up the data from the user interface, creates your amortization tables, and then data from this loan sheet is read by the cost of production sheets and the financial statement sheets. So we have options for all these loans that are already there in the system. For example, if you go for building loan, it will give you the amortization table based on the data that is there, that is input by the user. So once we have the loan information in place, we can actually have the financial statements and cost of production. Now these two sheets actually interact with each other. For example, some values are calculated in financial statements, and from the financial statements, some values are again picked up by the cost of production for break-even analysis and stuff like that. So these two interact. So these two sheets get updated simultaneously. Now let's first look at the cost of production thing. Say we analyze the break-even, so it has calculated the break-even details, the various details of the break-even sheet. Similarly, we can get all the other options here. We can have the energy cost, estimation of labor, and everything, provided we have correct data. Our data is just test data, just to check if the model is working fine. Now, financial statements, we have cash flows, we have the balance sheet, we have all the four primary financial statements that we need to provide in every report. So let's go to the income statement, because that's the primary important, that's a primary importance. Income year 1 is the one that is calculated, and income year 2 and income year 3 are forecasted from these values. So this is the format that we had. And one of the improvements that we are going to work on is trying to make this dynamic, in the sense that this different aquaculture production houses will have different kinds of income statements. So we like to make it dynamic so that users can have some flexibility as to choose the format of the income statement. So this is the current format that has been there from the version 1. So I'm sorry about the data. It's a huge loss-making industry, and I will not go into that. So that's the financial statements. Once the financial statement, the cost of production, and the loan information are in place, that data is used by the financial analysis sheet, which gives us the various ratios, so that financial analysts can actually analyze the model and suggest improvements in that. So for example, if you see the financial efficiency, it gives us the values. And this is because of one of the variables there. say we want the sensitivity, so it gives us the different ratios for an analyst to analyze and suggest improvement in the system, what things need to be improved. Now these cells are color coded. Whenever it is negative, it becomes red, so that visually you can say that this system has something which needs to be improved upon. So once the financial analysis, everything is done, we can go for simulations. If we have a very good profit-making system, we can try to simulate the model and come up with values so that we can have some kind of forecasted values for the future. So in the simulation, say I want to run a simulation for 15 variables, so just create values based on the forecasted values. As of now, we have just kept it for 3 years. We can extend it. This can be easily changed. So we have this simulation data. Now a visual representation of here. You finding the maximum value, minimum value, everything is difficult. So just a visual representation to add to this thing. So we can say that for the data that we have, it's between loss of 900,000 to and 1100. That we can.
There's a lot about aquaculture. You put the losses up there.
That's not.
Oh, I'm sorry about that. So this is a simulation part. Now we actually contemplated using a special software called Crystal Ball, but again we want this system to be strictly restricted to Microsoft Office, in the sense that people might not want to spend another $60 or $30 on something which you have to learn to use. So what we'll be doing here is we'll be using Excel's own data analysis things to generate normal distributions, and we'll try to provide some optimized values that if this is the input, this will be the profit and something like that. That optimization part is lagging because we need to work on the formulas. So, and this option that we have included, the help option, we felt the need for this very badly, so just integrated that. So this is our updated document.
Copies available.
Yeah, copies are there. And it's basically all the things that we have changed. And I'd like to go to the code part. This is the code that we have for simulation. When the first model was developed, what the primary approach of programmers took was they used to record the Excel macros, and they put that in the modules. Now this is this put in the restriction that it have to be in a particular place, because when Excel records a macro, it records it based on the system settings. So if you work on C drive and say record a macro, so Windows opens the application in that particular thing, and that link gets stored up in the macro. So when you try to work in some other system, it has to be exactly in those settings. So we removed that, and it actually developed all the code from scratch. There were no code there. There were just Visual Basic macros that were recorded and kept in the background. So this is just a sample code that we have, and I'd like to show you the.
Maybe you just like to add something here. Part of the documentation, each code segment, there is an explanation, documentation.
I'll show that to the module.
Oh, okay. Good. Just want to make sure.
So the naming convention, one developer area is basically the area where we have what changes you make, and each developer, whatever changes he makes, he'll note it down there, and he will have the details of the workflow there. We have these worksheets and the dependency there, and that is a developer area. And the naming convention we have followed here is 3 for version 3, and then the 40 sheets that finally resulted after we eliminated 10 sheets and different workbooks and merged all the worksheets from the editors. So this is a naming convention we have followed, and if you see the model, we have color coded the tabs. So liquidity, solvency, financial efficiency, sensitivity, equipment analysis. So the same color code refers to one particular aspect. Here the pink color codes refer to the financial analysis thing. So we have color coded and grouped it together so that users can find it easy, developers can find it easy to develop, work on it. And we have introduced a system to create sheets by the sheet number. So any sheet that will be created hereafter in this thing would be from sheet P41, 42 onwards, so that the thing remains. And here is our typical code. We have comments like this everywhere. And for example, yesterday evening worked on the budget estimates integration. So just put a comment in there so that if people know what changes have been made accordingly. And we have everything in different modules. We are not trying to duplicate effort here. For example, if we want to change anything to the look and feel, for example, if we want to make it full screen, we want to remove the ribbons and things like that, we just need to call these modules from anywhere in the sheet, so, and it will work fine. So that is how we have tried to modularize the entire thing. We don't know if we should be putting in passwords, because passwords and protection actually created a lot of problems for us. We had to break that password and then we had to work on it. So we have not put any passwords, any protection. If it need be, we can always have incorporated that into the model. So that is a model, and it over to Hussam to conclude. Thank you. Sheets.
Now, do you all want to open this up for questions, or do you have something else you want to summarize?
Just a couple of sheets. Just
okay, good. I'm not hurrying you. I'm just want to get in the flow.
I'll change it for you.
Okay. Now, what are we suggesting really for future work? Reducing some inputs if it's possible. Of course, we would need really an expert in the field of aquaculture really to give us support here. Enhance the simulation components. Now realize that we only, just for testing purposes, we only simulated some part of the user interface, not everything. Customize financial statements and probably have some facility to publish the reports in some way. Probably easier for the. If you go next. Now here is what I would like you to at least see how you can really see the work. You see, this is time, and this is the value added to the system. We are seeing our work. We are here. We took a long time to really be in this position, I would assume. Now, why do we argue that it will be an exponential component? Because of the enhanced system remodulation of the component, which would give future developers really easy access to the system. Everything is documented. When you read on formulas in the system, it's not based on columns or rows. No, it's based on names. For example, tank size is the total height of the tank times everything. All variables are to some extent clear for the reader to understand. That's why we think that in just a couple of more months you'll see also a major improvement, much more than what has been reached until now. That's probably here are some references. Probably we're gonna if you have any questions or answers, you can click next also. We can also open this for discussion. Maybe we can have the lights on.
Okay, you've heard the presentation. Please feel free to answer any questions. Before we do that, Dr. Zobel, Business Information Technology, Dr. George Flick, Dr. Laura Marsh, Dr. Greg Boardman. Greg is a civil engineer, been here at Tech for a very long time. Now, I would open the floor to questions and direct your questions to any of the speakers, or they may want to have a discussion and then come out with a consensus to your answers if that's necessary. And you know, they've laid out a very broad perspective here. Now it's time to get down to the details.
I had a question, Charlie. We looked at minimum and maximum values in your program. So people put in the minimum they expect to pay and the maximum they expect to pay for a certain objective. Is that correct? Then they come back and put in a real one, or does the computer?
Computer generates.
Huh?
That's a computer generated.
Computer generated.
You just give in the limits and it automatically generates a value randomly between those two limits. So every time you run the simulation, it generates a different value between those particular limits. It's always a difficulty for a person, to give a specific value. So he always knows that, okay, this is my range. I think that I'm going to invest this much in this. They can give in that range, and within that range, they can just introduce a particular value between that range automatically.
So the computer picks that automatically.
Yes.
If you wanted, could you make the upper and lower range the same?
Yes, you can.
Yeah, but then it will be the same single
Right,
value.
but if you
We have
felt
given
very
you the
confident.
flexibility. You can define the upper and lower limits. Then computer generates all those values, and then if you want to keep some values fixed, you can go manually and change those values to whatever you want.
Well, let me say, first thing is, I think what you have there is a great tool, because most of the people in the industry that we've worked with over the years don't know if they're making money or not making money. They know when they go bankrupt that they didn't make money, but before they get there, and many of them don't know the cost of what they do. We've seen that over and over again, where people buy things and really have no idea what the cost is. They pay the total bill, but if you ask them what did that individual container cost, that they have no idea. And so many of the costs of selling a product is based on just pure guesswork. So many of them are losing money. And if you look at the industry, you have a set of names. 3 years later, you have a new set of names. 3 years later, there's a new set of names. When I came here, we had 70-something crab plants. I think we have 2 left out of that 70, which means that people have gone out of business. They're constantly coming in. So I think what you have there is, to me, is a great tool. That people can then track and see what they're doing.
Now, George, let's talk about estimating in error terms. Lori and Karen and I worked on these budget profiles, and they have integrated the first one on employment. Now, one of the things about estimating, before we put in the fringe benefits, we were grossly underestimating the employment dollars that went into that model. Now, when you can look at that worksheet and you can say, this is what the labor deal looks like, and then you go into their model and you put an upper and lower limit, and you can tighten that up, but you then have much better information. There is also a worksheet for feeds and feeding and the system. What are the components? This is a fixed cost part of the program. Lori is an expert in energy management, and there's got to be also a worksheet developed for energy. Now, when you cover all those bases and then deal with the facility structure, the land, and those kind of things, then you really have that model tightened up.
Well, I agree, Charlie. I heard that when you have ponds, the most expensive part of the pond, because people had the land. I mean, they do economics a little differently than you do it. The land's already bought, so it didn't cost anything. And they say feed is the most important part. But on this system, I can't tell you whether it's people, feed, or facilities. I don't know. I can't rate. What's number 1, what's number 2, and what's number 3 in cost. I have no idea. And I've worked with these companies for 15 years now, maybe 20. And I have yet to come up with a really good idea as to what percent feed is, what percent labor is, what percent facilities are. So I think this is, to me, a golden opportunity for folks to find their cost and start learning how you build a building, you know. We overbuild, we underbuild, we have no idea what we're doing. But, so I think what they have here is a great tool. Bill Martin said, you know, they would use this. I think the shrimp facility would be a great one to start in, because it's just getting started. It's a $3.5 million investment that has a great potential to go bankrupt. You know, so it would be great for them to see that cost early on, to see how they may manage that facility to prevent, you know, the disaster. You know, Greg, I mean, it's a high risk. Everybody knew that from the very beginning. So I'd be willing to work with Bill, see how we could get his secretary, who probably has a lot of time right now, to implement that. Now, this is not complete, from what I understand.
No, and we need to deal with that so we can get it complete.
I talked to Terry, and she said we would do what it needs to be to make it complete.
Okay, well then we can talk about that after the question and answer period, if that's all right.
Yeah.
And Chris, if you got some time, I'd love you to stay and advise, you know, because this is a comprehensive undertaking. And if we can get some good estimates in there, then it helps the budget people downstairs understand, you know, what has to be earmarked.
I think they did a great job, from what I could see.
Oh, you bet.
Pulling it together with, what, 6 or 7 workbooks. Now we have it all in one. We have ranges on it, which are probably good than just a value.
Yep.
So,
and you know, this thing has been a progression, and we have not put a great deal of funds into it, and this is really the capstone of you know, where we need to be at this point.
Did you have any data set to validate this thing?
No.
It was
With
just
the
the
initial
one-
model, we had all the values in.
Right.
So we just, Dr. Charlie first, initially we did password, so we could not see the values. Dr. Charlie got the prints for us, and then we entered those values and found that it's negative. And went back to that model and checked. Even they had a negative profit, so.
And that was a Southern States model. So it was an operational system that had been running probably 5 years. I think you see all those red numbers and you say, oh God, it's not going to work. Well, this, if you account for all the costs, I guarantee you that you're going to run into negative numbers in those performance on those simulations.
On that break-even analysis, is that something you added? It was already there. I didn't realize that. It showed a price of like $216 a pound as your break-even. That's a little discouraging of a target.
I thought I saw $6,900 per pound on there.
Oh,
It's a high fixed cost industry.
yeah.
And if you look at the economies of scale, you know, it takes.
well, it goes to what I'm saying. You can't sell the shrimp as a processed product. It's going to have to be a bait, or it's going to have to be live in a oriental market, or it's going to have to be organic. You know, it's not going to be a processed product.
They haul their fish to New York and Toronto and Philadelphia and put them in the aquarium. And people buy them out of the aquarium. So they don't have any processing costs. They don't have any throwaway. I mean, that's a significant deal, because if you took the fin fish that we culture, when you fillet it, 50% of it's trash that has really no economic value.
Huh?
Like 70, I think. About a 30%.
So obviously
yield.
over 50. That's close to
Well,
40, 37.
then you make my point easy.
Yeah, right.
It's worse. Well, I think it's good, Charlie.
Well, good.
I
Now,
appreciate all
Now,
that.
how do we then proceed to talk about doing this? Some showed you where we are on the curve. You know, you three are going to be here during the holiday period. Is that correct?
I'll be off after 22nd.
All right. Well, let me ask you this question. As a team, I never saw the peer review of who did what. Can you work together and do the checks and balances, and you know, with the time you have in your graduate program, You know, can you devote a sufficient amount of time to get this thing done in a reasonable period?
We'll have to discuss that.
What did he say?
We'll have to discuss that.
They'll have to discuss it.
Is that-
They'll have to discuss it.
Yeah.
Yeah.
Because
We're not really sure of what kind of much support do we have, as we have 2 MBAs. I'm an information system. Many questions we have are really hard for us to understand or to get or research, because many of the models are really, you need an agricultural analyst. Many formulas are there, for example, how much the sodium does affect the number of fish produced by the end of the year. Things that we really don't know, and that's why as a team, it depends really if we're going to work on it to continue on, how much information and how easy information can we get.
Well, I have serious concerns about the energy module in that model, and I'm prepared to give you the formula, what you need to make that one work. If you can do the programming, I can sit down with you and provide you with what needs to
That
go
would be
in
really
there.
good.
So just to get that piece fixed is really
If we get the inputs straight out, the inputs that are there, straightened out, then we can develop it in a more, professional and here we're just trying to correct old code and introduce new things and show that it actually works. It actually works. We need good data, good ratios and all those stuff.
And then Charlie, Karen and I have worked fairly extensively coming up with some of these new sheets and new inputs. And some of the, we don't truly anticipate modeling the growth of the fish. I mean, I think that's going to be a user input basically.
Yeah.
Where you expect to be at the end of the growth. We have some feed conversion ratios, some very simple models.
So there is, if we can get that input from you, that what is the scope of more enhancements that you need into this, and what different things you want, what different changes you want into this.
Okay,
And
you
it would be better for us to decide what time it would take us, and based on what other commitments we have. And
Well, I guess it seems to me we need to find out what they need.
Yeah, well, yeah.
I mean, we said that the energy model has to be improved, right?
Right.
Then there's another model. So I guess there's several sections of this program where they need information that we will have to get.
Well, yeah, but we've got the program of work here pretty well laid out. So, I think you need to read that. And then I think you need to come back with a series of questions that are not covered in this. And that way, it's a trial and error thing. I mean, we've been working on a trial and error basis. And sometimes you make small steps. And if you just pass that to those folks.
Well, I think recirculating aquaculture, for them, it's going to be where we're going to see, because water is very limited. I know if you think it's limited in Saudi Arabia, it is pretty limited, but it's also pretty limited here. We're now looking at allocations out west in Idaho, where the aquifer for the trout is very limited. They've over allocated the water. The aquifers around are running low, the lack of rain. So we have the same problem you have, maybe not as severe. Right. And this could be everywhere. It's just not here in the United States. Net pens have inherent problems, flow-through systems. And if we look at the fish, an argument was made, right? If we look at the population and look at the increase in fish, it's dwindling. In other words, our population
Human
growth
demand
is
exceeding.
going to be greater than the ability to supply the demand for fish. And so we're going to have to look at, improved systems, more efficient systems. So I think what I see here is, to me, it's very exciting, to be
Well,
perfectly honest.
Then what we need really, I guess, is a proposal on how much time it's going to take. What kind of payment compensation would each, and we'd have to pay you, to be fair, we'd have to pay you the same rate. And the way you have worked independently and then merged this, isn't that correct? You've worked on pieces of it and merged it. So if you could use the same strategy in your model development, I think that'd work fine, because you're gonna be here a little bit, and you may be here, you may be here. And what's critical from my perspective is that you work on campus, and you're students, half-time students, so you're gonna have some real restrictions when it comes to the spring semester. And I'm, concerned about that.
I'm not sure.
So-
A lot of it has been done.
Oh. Well, what's been done, we can cross off. I mean, when did we do this, Corey? I didn't put up the date on that. We probably did that 3 weeks ago.
I'd like to ask you a question.
Go ahead, Greg.
Please. Yesterday I was given a clock, and when I opened it up, on the back it said, open battery compartment, number 2, insert battery. That's how it went for about 4 steps. If, with your model, if somebody comes to you and says, I have 6 tanks, I want to grow a perch, and I want to know how much money I'm going to make, how much I should charge. If you go back to your first page, what's the first button you push?
It's user interface.
Okay.
We have these different options where there is variable cost information that's specifically to the tanks and the concentration of different materials, equipment cost information, electrical component information. Once you fill what you know about these, you'll get the results from these buttons,
And,
whether it's a business
We have
analysis.
actually put up a user guide here in which we have described the stepwise method to approach this model. Working with user input is the first thing that you need to do. So it has all the buttons that are there, then it tells you what values to enter, how to use the values. So it takes you step by step to the entire model.
This is installed with the
for
models.
users to use it, because when you see a lot of buttons and where do I start off?
Right.
To help that.
So the user interface is all of your input data. So everything that goes, the real skeleton of your model is there under user interface.
This is the inputs process. This is just the inputs. You input the
That is the only sheet where you input the data into the system.
Okay.
Do you want to maybe call it data input instead of user interface? That might
Yeah,
be
this
more
should be-
useful, maybe.
I mean, we just use the same word
Yeah.
in version 2.23.
So
It's really
it's
confusing.
this AEC and version 3 user interface is there, and
This is the inputs. It used to be just the inputs, but now we just merge them
merge
together.
everything together.
And in your user manual, I mean, what you just showed me a bit is what you said is also available in hard copy, I guess. No,
It's also
you can print it out.
Yeah, it's in hard copy, and it's also you can open it for the system. The papers are and the documentation is with the system. So there is a button
It
where you
just
can just hit help
you get the help
and you
of
can access the. That's
this is the help button that you have. So if you go there, you'll find these options.
And this is really basically what I feel personally is the major thing that happened to the model is incorporating the documentation and the help to it. Otherwise, it's really hard, even for the developer, to really speed up the process. There is a user option, for a casual user, how to use the system, a developer guide. Also, the previous paper, we have our paper installed within the folder itself. And also you can access the version 2.23 paper that was also produced.
I think we might be better off disabling this button initially when the model comes up so that user doesn't get confused. You have the user interface, you're very good, where that's the only thing you can click on. So you click on that, you get the user input. You input those data, and then gradually, as the model goes, the button will be enabled that way so that you can go through. I think we should have done that.
Adding to Chandan's point, this was really the idea when we received the system, to the extent, even we try to have some control. When someone clicks on user interface, the user will not be flexible, only focusing on specific cells. But this is this just happened to contradict with the developer's way of, they want everything flexible. Unless we want to put it into deployment, I think this is what the idea would turned out to be. I mean, some guidance in the process, but you have a really good point in that.
So you're saying put the help button, the first button in Joe?
Yeah, only the help and the.
These are hidden, these can't be hidden. The other button, I mean, one's the first one, he only sees one button at first. Like a step by step, a wizard-like guide, you know, that tells you now you can do this and now you can do that.
Yeah, yeah.
So
Maybe you could have two buttons, inputs and outputs, but, and then this could be sucked in the output.
Yeah, we can imagine.
Yeah, something like that, but, yeah.
Now look, these guys struggled as to what this thing is. So you know where the pitfalls are, so you know how to correct them, right?
They've gone a long way to do that.
And I agree with that. Oh, I don't disagree at all.
Well, a lot of those user input sheets we have now simplified. And so getting that incorporated to what we did. I just nodded a lot. Good job.
And I think this probably came in too late. I don't know if there's any potential in the future, but you know, with John Simon's thesis, have you looked at that thesis?
Yeah,
Have you had a chance to see that?
Oh, absolutely.
Okay. Now that's a simulation using different software and all. Is there a way that can be interfaced with
Yeah, we
this?
can interface that. We can look into the possibilities. For example, we have software like Crystal Ball, which we can interface with this model, but we don't know how much users would be benefited by that, because learning a software itself is a cost, has some cost associated with that. So if you want, we can, if everybody wants, is okay with using third-party software, which can run the simulation and generate concept. It's very simple to integrate that.
That would put some constraints on the system as well when we are deploying it on different machines. If I'm putting it on your machine, you have to have Crystal Ball on your machine to rework with the system. So those are certain things that we need to consider before we, interact with any third-party software.
Excel is actually readable by most of the third-party software. Like if you go for statistical analysis, Minitab will read Excel spreadsheet easily. And I think in Crystal Ball, for optimization, I think we can just copy the entire ranges of cells and paste it there for the data to be used. I think there is an option for that. So I think Excel provides a very user-friendly interface for working with third-party software, even if it's not merged with the system. And merging itself is not very difficult.
What can we do is just keep a model as Excel itself and provide certain documentation about how to use Crystal Ball with it. So that if you want to use Crystal Ball and you know how to use it and you have it on your system, so you know how to get the data from this system and put that into Crystal Ball and you get your results there. Or any other software that you want to use, which are a good for simulation softwares in the market. We can just research on them and provide some documentation that given this model and given this data, how can you use this data to be put into that particular software and generate those simulation results. So that will keep this model as an Excel only, so that it becomes easier for the users, all of them to use it. And for the advanced users who want to go ahead and take a step ahead and move to Crystal Ball use or any other software, so they can go ahead and use this particular data into those particular softwares.
Have you got Crystal Ball when you set in those iterations? Is that Crystal Ball?
No.
That's random.
Random numbers.
See, the more simple you can make this sucker, use it internal. The functions that are internal Excel, I think the better off you are. I mean, if you're investing 100 million instead of 10 million in this, it might be useful to get very precise estimate. But I think the estimating functions that are enclosed in Excel will do okay. I mean, you just run it a number more times, right? If you're not happy with 15 times, you run it 600. Is that right?
And those all the same uniform distribution.
Yeah.
I like your suggestion that this is independent and then the information could be then you could describe how it can be used in other software. I like that. The only thing is, from my perspective and what John Simon did, it's more a matter of getting that information to this, as opposed to the other way around. Because in his, it was to be more of a design tool. Should we operate the blowers all the time? How much should we recirculate? What rate should we recirculate? And trying to go then to estimate power costs and that kind of thing. So I think out of that work could come some numbers that should be imported into this. And I agree. Yeah, I think that's probably the kind of linkage I'd like to see.
And it was also a thesis done in Ag Econ that you all have that dealt more with distributions. I mean, price distributions are really important too. I mean, the higher the price, the smaller the option that'll be selected. You know, with this model, they'll never get up to $959.
We ran into the same roadblocks that you spoke of a moment ago, that the numbers weren't available. We tried to go to Southern States. We tried to go to Mike Timmons at Cornell. I don't know if you've heard that name, but he had started up some tilapia recirculating system. We talked to somebody in Missouri. We went round and round trying to get some realistic numbers that John could test out with his simulation, and nobody wanted to share the information. We went to our own aquaculture center, and we couldn't get all of the values because they weren't making the kinds of measurements that we needed for the model. Okay. So we put in what we thought would be reasonable, and that's how John had to leave it. And that was really disappointing because when we started out, we thought we're going to get some real world data and put it in here. And I think that's the problem that you're going to have in finishing it off in the way that we suggested. I don't know that anybody will share any of that information.
However, the way they have structured this thing with the maximum and minimums, you take previous knowledge and experience and you can tighten up those limits. And it may not be what you want, but at least it'll give you some feeling about where you're headed. I mean, if you put those limits in and do the most conservative limits you can find and still find negative numbers, you better not be in it. Right?
That's not very entrepreneurial type
Ag Econ, remember?
We're pessimists.
No, that looks really good. It's a good job.
You indicated there's some kind of sensitivity analysis in there?
Yeah, that was already there in the model.
What did that consist of?
Some of those ratios.
This is really.
Oh, it's really more the ratio.
Yeah,
not
included from version 2.33. Aside from that, one of the improvements that would be now easy to do because of how abstract the references are, how to increase the number of forecast years. So now we only have 2 to 3 years. Now what we can do is really easily just delete the second year and the third and have the system that automates the rest of the number of years. And this is just now it's a really easy component to add.
You might also go ahead and reduce the number of inputs because there are a huge number of inputs. So just like to make it more dynamic, whatever the user wants to input, and have some formulas which will calculate the values for them to generate income statements for X number of years or whatever they want. Just to make the system more dynamic and smooth.
Now we are told that feed, labor, and energy are the 3 most significant inputs in this system. When we met with the feed guy, Lori did this, we only got fish that were going to grow to be 1.5 pounds. Now, are we going to grow fish that are more than 1.5 pounds? And what are we going to do about those limits on those feed ratios?
Well, now, if you're raising cobia, you might raise them on salmon. You are going to raise them to more than 1.5 feet. Bill's going to go over to West Virginia. What's the name of that thing? West Virginia?
Freshwater Institute?
No, he bought Minocca. The
Oh,
old Minocca.
a new plant.
At Man, West Virginia. I I got the name of the company now, but West Virginia something, they're gonna raise salmon, you're talking about 5 pound to 6 pound salmon, because the fillets are 2 to 2.5 a pound. So those fish are that big.
So is that a simple calculation?
Yes. Just
Okay.
get one more feed conversion.
No, just saying, they ought to be more than a pound and a half. A lot of
Well,
them may be a pound and a half.
Is that data researchable? I mean, is that data available to?
Well, and it might have to be a user input. I mean, they may have to make, and it certainly would be something we want ranges on, feed conversion efficiency.
That means no, right?
I guess. I mean, I don't think we really know how well they'll be growing the tanks.
I think that's a problem.
Well, they
All
grow
this is
pretty
new
well out the
technology.
aquaculture center. Hussam and I and Dr. Zobel were out there looking at it.
Right, but we don't know how well they convert feed as they get bigger and bigger.
Well, you and McLean said they do it pretty well.
Right.
Am I missing the boat, or is that?
No, if you
Kind of
want
hard
to
to
put
put that
number
down
in
there.
there, pretty well.
Pretty well.
Yeah, can you type in words?
I think the problem, Charlie, is that feed conversion for most fish, it's pretty good at first, and then it starts
Well,
leveling off.
it's
You know,
That's-
sort of
it's
like
not,
the
not
Tom
linear.
Douglas.
It's exponential, you know.
Yeah.
It may be an inverse exponential.
Okay.
Well, those are some interesting things. And,
Well, I guess I'd like to see the next step. I think what I see, I mean, we sitting here saying that we don't know what the systems cost, we don't know what the production is. And so, to me, it seems like a model like this would be more useful. If nobody knows anything, it seems to me that somehow we ought to have those figures. I mean, here people want to get in business, and I've worked in this industry for almost 40 years, and you ask me what the costs are, heck, I don't know.
well, but it is still
Yeah.
an estimate. I mean, any business you're in is going to be an estimate because the future is uncertain.
If I grab a memory stick and you give me a copy of what you have so far?
Yeah, sure.
Okay.
Now, the next step, the immediate next step, you guys are going to put your heads together and develop us a proposal for your work effort in this. Is this correct?
Do you have any timelines? Do you have any timelines within which you need to finish this thing, or you need to have a model?
No, because it's been open-ended, but the point is this, if you can get it done during the holidays, or, you know, get a lot of it done during the holidays, at least get the conceptual work. Because we're gonna run up against the problem with paying you. That's what I'm saying. And you gotta work to get paid. So you can't say, well, I'll do all this on weekends and then,
I can put in 8 hours because I'll be staying here. I can put in 8 or 9 hours every day
now.
But during the holidays. But when college starts, when classes start, then I might not be able to put in 8 or 9 hours every day. I'll be able to put in just about 3.
Yeah, and I don't wanna back you on a corner. I mean, y'all have just been magnificent to work with, and we wanna capture what you've done because, you know, you understand this better than any other programmer we can put on it right now because of your background in investigation. Now, I'm gonna be here Monday and Tuesday and Wednesday and Thursday. Can we get together Monday with a proposal so we can get this thing hammered out?
I'm not gonna be here. This, probably next week is really gonna be full.
Okay, now what about this weekend? Are you gonna be able to give your input
Maybe,
this weekend?
maybe by Saturday.
Yeah.
But, I don't think that I'm gonna be able to work this holiday because in this period I need to apply for a PhD and it will consume much of my time. But if I'm gonna be working on the model, I do believe that I can do that by, let's say,
After 14th of January?
yeah.
Yeah.
That's it.
So if y'all can mix and match, you know, this is one of the best examples of entrepreneurialism and your ability to do things as a team, to communicate with one another. I told George down in the office, I said, if you don't think globalization in business is real, you listen to these three guys because they'll make you a believer. So, you know, if you can do what you've done, you know, work together and cooperate together and and you obviously have magnificent skills that fit together really well. You probably see a corporation with your names on them in 10 years. So, you know, if you can do that, and if I can get a proposal Monday, then we can start to move this thing through, and he can take advantage of his time here, and you're going to be gone a little bit, and you work for the, after the 14th of January. Does this sound reasonable, Chris?
It sounds reasonable, and I'm coming in, not having been in the middle of it. Do you guys have a good conception of what still needs to be done?
No, that's what I was saying, that if they can give us those inputs that what exactly they are expecting more of the model, what changes they want, what more enhancements they want.
So
We can
you need
propose.
an energy model, you
Yes.
need all that stuff. Yeah, I would think that that'd be easier for you to decide
Yes.
how long it's gonna take you if there's a little bit clearer what the chunks are that still need to be filled out. So maybe, you need to each provide a piece of that.
So, we're going to be here Monday.
I will be here. Yeah, I'm pretty open.
But I'll have my bus only at 9:15, so I should be here right. Because holiday periods, the buses don't come.
At 10 o'clock. I
10
mean, at 10
o'clock.
on Monday.
Then on Monday.
And
Okay.
if you have all the spreadsheets you've developed, I can bring in some of the.
They have.
Oh, so you already know what
Oh,
Charlie.
God, I sent them everything.
Oh, okay. So, and the energy piece, I would think,
The energy piece is going to take some programming
it
because
will take some programming out.
because Lori is
Programming
concerned.
is not the problem. The
Yeah.
problem is the
Concept that we need to know.
Yeah.
and
Lori
what is the
can-
logical end of the thing.
I think I can.
At the speed you're going and the speed she's going, she can take what she developed, and it's that narrative. It's the energy narrative that you have, and you can have that thing put together in 2 hours.
Basically, I have weather data for all the cities in the U.S., which is just an accumulated degree date value, and we just need to ask the user what city they live in and incorporate this weather data, which is from NOAA, our national,
Which is what you're talking
from
about.
our National
Yeah, it is
Weather
NOAA.
Service. It is
It's NOAA.
NOAA, right? And it's public. It's usable. I mean, it's not copyrighted. The data can be stuck right in. So there's just a few inputs. It's not too big of a deal.
How many megabytes is that?
It's the weather data.
Yeah,
Well,
it's on one disc,
it
right?
came on 2 CDs, but the
Okay.
portion, but the portion I want incorporated probably prints out on 5 pages.
So
it
they
can't be
probably
much.
can just put that right in the.
Oh yeah, I think it's
model.
tiny.
Put that in.
Absolutely. So the user just has to pick their nearest city. Pretty much. And then use the.
Just the most merciful. This is something from my religion. We start in everyday life. If you want to start work, you say Bismillah ar-Rahman ar-Rahim. If you want to do anything, you say Bismillah ar-Rahman ar-Rahim. And this is Sanskrit. I searched online just to bring also my friend's background to my best of my abilities. I'm not sure really what does this understand. Probably can help me out.
So those are just the alphabet of Hindi.
Concept of
actually.
yoga
It's
and all
not
those things, that Om is a way you identify yourself with the God.
And all 3 columns relate to the
Yeah, those are the same
Different-
alphabets in 3 different languages.
3 different languages.
This is Sanskrit, right?
Yes, it's not exactly Sanskrit. This is Hindi.
This is Hindi.
Oh,
This is Hindi. Sanskrit is a bit more complex than
more
this.
complex. Search like
That's
that.
okay.
I tried.
Well, we appreciate every hour and every ounce of intellect that you all have put into this. We are very sensitive to intellectual properties, and we want to make sure that everybody gets credit for what they've done.
We would like also to thank Dr. Charlie Cole for giving us this opportunity. It was really a nice experience. Professor Christopher Zobel for giving us this support, even though we had many problems. He really gave us the support and the many green lights to do. Dr. Ewan McLean for giving us the opportunity to see the agricultural plant in detail. Travis and Jennifer, who developed the, I believe, the
Founders
version
of the
1.
model.
Yeah.
Founders of the
I think
model.
they are the
So-
ideas behind version 3.
So
They told
yeah.
us what it means.
Yeah, we thank them, even though they're not here, we do really thank them a lot. Thank you all for being here.
Hey, Joe, I think y'all would benefit too by seeing one of the facilities. I think when you look at the Aquaculture Center, you see something really small scale, but when you look at the actual facilities, they're tremendous. And if one in the shrimp facility, the filtering and water treatment systems are massive. So I think it'd be good for you all to see what one looks like. And perhaps we could, maybe Charlie could take a tour if they had time to go down and take a look at Martinsville if they wanted and see, because they produce 80,000 pounds a week, maybe up to 100,000 pounds out of one of those facilities. That's a lot of fish. And that's only one facility. So it may be good to see what's involved in it.
Well, you and Lori have the entry point into that, so
Yeah,
anything you'd want to do.
Make that ask.
Huh?
You'll have to arrange that with Bill, but we'll see.
Yeah, I don't think Bill would have any objections.
Now, I don't mind riding down and, you know, get a mutual time that y'all are available. Because it is a different operation than what you saw at the center booth.
I can't see Bill having any difficulty with that, especially if we can take the model, it's gotta work. And the more it works, the better it all.
Well, the phone call will determine whether or not.
Oh, I can do that, yeah. I don't have any difficulty.
All right, now, where do we stand? Monday here at 10 a.m., is that where we're staying?
Yeah.
You and,
Anybody you can.
but you're going to be out of here, right?
Yeah, I'm
And
gonna be visiting those.
you'll be here?